Hi, my name is Robert Ponce, and today we're going to be proving if a quadrilateral is an isosceles trapezoid, the diagonals are also congruent. So with this information, we are given that line segment um, B and C, or BC, and A and D are parallel to each other. As you see, we have a line indicating that they're parallel. And then line segment AB is congruent to DC. So with this given information, we're going to try to prove that line segment DB is congruent to line segment AC. And so before we begin, we're going to go through a couple of refreshers, starting with reflexive property of equality, which states that any value is equal to itself, and also the parallelogram opposite side theorem, which states that opposite sides are congruent within a parallelogram. And then for the transitive property of congruence, it states that if a value A and B are congruent to C, that makes a value A and B congruent. And then the isosceles triangles theorem, which states that if two sides of a triangle are congruent, which creates an isosceles triangle, then the angles opposite of those two sides are also congruent. All right, so to start off, we're going to create an auxiliary line that goes through point C that is parallel to A and B. So as you see here, we have a line segment created that goes through point C that is parallel to A and B. And then when this line segment goes through AD, we're going to call that point of intersection point E. So now that we have line segment EC is parallel to AB, as we can see down here. Okay, and now the quadrilateral that we've created, A, E, C, and B, as a parallelogram, because now it has two pairs of parallel lines, which is the given AD, which we can now put AE as lines. The point E is on that same line segment, so it still keeps parallel, and it's parallel to line segment BC. So that's one pair, and the second pair is the one we proved earlier, which is EC is parallel to AB. So with that, we have proved that there's two pairs of parallel lines inside, and we can say that the quadrilateral AECB is now a parallelogram. All right, so using this information, line segment AB is congruent to line segment EC by the parallelogram opposite side theorem. As we said earlier, this means that the opposite sides of a parallelogram are congruent. So now we have line segment here AB is congruent to EC. And then using transitive property of congruence, we know that EC is congruent to AB. And AB is congruent to DC, which is given at the very start. And since EC and AB are congruent, we can say that EC is congruent to DC. A little bit of a mouthful, but yeah. So you can see that these are equal. And then EC is congruent to AB, and then AB is congruent to DC. We could say that now these two are also congruent. So we have these three line segments that are all congruent to each other. So EC is congruent to DC. Oh man. And that was a little bit of a mouthful you can see right here. And so the triangle DEC is an isosceles triangle because the line segments EC and DC are congruent, as we've said earlier. And since DEC is an isosceles triangle, the two opposite angles of the two congruent lines are also congruent because of the isosceles angles theorem. So as you can see, the two opposite angles of the line segments that are congruent right here. So angle CED is now congruent to angle D. Okay, so since line segment AB is parallel to EC, and then they go through the parallel lines BC and AD, this is going to show that angle CED is congruent to angle A as per the corresponding angles theorem. So using a transitive property of congruence, we know that, we'll just call it angle E for now, a little shortcut. Angle E is going to be congruent to angle A as per the corresponding angles theorem, that C, or angle E, and D are congruent because of isosceles angles theorem. And since now we have that angle A is congruent to angle E, and then E is congruent to angle D, that means that angles D and A are also going to be congruent, as we've said earlier now. So angles D and angle A are now congruent as per the transitive property of congruence and the corresponding angles theorem. And a little cherry on top, the line segment AD is congruent to itself because of the reflexive property equality, which states that any value is equal to itself. So AD is congruent to AD. A little fun. Now, we're going to have triangle BAD be congruent to CDA. And then we're going to prove this by using the side angle side congruence theorem. So we are given that line segments AB and DC are given to be congruent. And then we have proved earlier that angles D and A are congruent. And then finally, line segment AD is congruent to itself because of the reflexive property of equality. So with this, we now have the information to prove that that triangle BAD is congruent to CDA because side angle side, as we have two sides and an angle that are all touching. So because of the side angle side congruence theorem, we have triangle BAD is congruent to triangle CDA. And since triangle BAD is congruent, BAD here, I know it's a little hard to keep track, is congruent to CDA, the line segments DB and CA must be congruent as they share corresponding parts of the same congruent triangles. So now we have proven that line segment DB is congruent to AC.